And I will also give you recording rights to everybody so that you can also record it on your desktop, and that's how it's going to be daily. Okay, guys, everybody's given recording right. You can record it on your desktop or your laptop or your cell phone. And now we'll go to the data center page. And here's the syllabus. I'm sure you guys have visited this page before. And excuse me. Everything was silent. So we are going to basically do chapter 1, which is going to talk about the theory. It says describe, 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 describe. Here you see that all is describe. So CCNA is more about describe. It's not about configure. And if you look at the CCNP level stuff, you will actually see a lot of stuff called configure. But here is going to be more like describe. So this is more like a theoretical stuff again. Then we'll have second chapter. So this is more like describe the basic concept of NXOS. What are the NXOS operating system, benefits and other things. What is different about the data center switches and all that. Then a little concept about VDC, the OTVs, virtualization, again VDC, and a lot of other stuff here. And then we have fax, port channels, VPC, fabric path. If you see that, it's more like describe again. So CCNA is going to be more about describe. So then we go to the UCS, where we have to do more of UCS stuff here. Then UCS directory is covered and ACI is also covered. And here it is, some portion of it is basically that you configure is also there, but most of the stuff is like describe. Okay, so that sets the expectation that we are actually going to do CCNA level stuff out there. Yes, any question, any doubt, any point that you have before I start the class?
Vikas,
yeah.
Nitesh, can you hear me?
Yes, Nitesh, I can hear you.
Hey, Vikas. When we look at the CCNA certification courses for data center on Cisco website, it's divided into 2 parts. And it also talks about storage virtualization as well in this, where we're going to do iSCSI, SAS, and all those configuration as well. Are we not going to cover that as well in this?
No, that will be more like theory. So iSCSI is not part of the Cisco devices. Most of the Cisco devices do not support iSCSI because Cisco is actually pushing for FCOE, which is
fiber channel.
Yeah, fiber channel over Ethernet, basically. So FC is an old standard. iSCSI is gone from the market.
Understood.
So Cisco basically, the focus is on the FCOE standard. So we will cover FCOE in detail. In fact,
we're going to cover vSANs, virtual storage area networks, and all those things, because that's what is written in the CCNA data center.
That's correct. That's correct.
Okay, we're going to cover that. Okay, perfect. Okay, I wanted to check with you because I basically work in Citrix in a virtualization platform. So I was a little confused to understand. I mean, because I'm trying to get into the network virtualization as well, and I don't have much now. I work on the hypervisor virtualization, but I don't work on network virtualization much. So I wanted to see if this is the course that I need to go for, which is going to be helping me to understand network virtualization. Is that correct?
Yeah. So some portion of that will be basically covered because it has ACI. And it will have different kind of virtualization. So today we are going to basically talk about VDC, which was actually almost similar as compared to your ACI, where you can virtualize your switch. And further, you can virtualize a lot of stuff. You can virtualize your routing, you can virtualize the switching, you can virtualize a lot of other components. But yeah, the true network virtualization will actually come in the ACI portion.
Oh, okay. Yeah. So network virtualization is only in the mostly in module 5.
That's correct. Yes.
Okay, but to go for network virtualization course from Cisco, and this is the course to start with.
That's right. It will give you the base fundamentals. So once you have the base, then you can go for the advanced ACI programs.
Okay, okay. But I'm still trying to understand because I work in virtualization environment from quite a few years now in Citrix.
Mm-hmm.
So I'm just trying to understand if this is the platform for network virtualization understanding.
Right. So Citrix and VMware are pretty good when it comes to the OS virtualization, server virtualization,
Correct.
and the host virtualization portion of it.
Uh-huh.
And Cisco is more on the networking side. So Cisco is pretty good into the
Network virtualization.
network virtualization, which is device virtualization, basically.
Okay, cool.
Yeah, but it has a lot of integration with the host-based VMware or Citrix or Microsoft, even cloud platforms that you can
Interesting.
seamlessly integrate with these.
Are we going to discuss about that as well, or no?
We will see. So VMware and all that we can basically cover.
Sure. Cool.
Yeah.
Okay. Thanks, Shrikant.
Sure. Guys, anybody else has any question, any point that you want to discuss? Okay. So I see that a lot of you guys in the batch. In fact, I have Vijay, my student, who 7 years back passed CCA security from me, and then I see Nitesh and other people who are pretty experienced. But as part of the syllabus, I still have to cover very basics. So I'll just refresh some basic fundamental concepts, and then we will go into the advanced stuff. So. Okay, so as you know, Cisco product line is basically divided into, you can call it enterprise products, which you have seen, Cisco CAT switches and all that. Then you have service provider. Then there you have IP telephony. Then now they have data center. And then they have wireless products. And these days they have server products. They have virtualization products as well now, and they have automation platforms. And they have their own SAN. So these are basically the Cisco product line, and then they have security products, which is huge range of products, around 20 products in Cisco products, security product line they have. Okay, so basically we are going to talk about one piece of it because Cisco has a good grip on multiple platforms, and sometimes we get confused. So enterprise, the iOS series, right? You have worked with iOS series products, your CAT switches, and the old any catalyst switches or iOS switches basically coming to the iOS platform. That was the operating system. Then service provider, Cisco had something called XR series. IP telephony has its own OS, right? The CUCM and all that. The data center may be majorly what we are going to discuss is going to be on Nexus OS. Wireless again is more on iOS plus its own software, the controllers and everything else. Server is more like UCS when we talk about, and huge number of UCS different platforms are there now. So we have M series, B series, E series, S series, and a lot of other series of products. I'm just giving you a brief basic idea about the different product lines Cisco has. When we reach to the UCS, we will discuss more in UCS. I will explore all UCS products Cisco has. I'll explain you about all the B series, M series, E series, what is their use, where do they use it. Plus in UCS, we will also discuss UCS Manager, UCS Central, and all these things. Virtualization, Cisco has Cisco soft switches, which is like 1000V plus APS plus some more soft switches they have. Automation platform, a lot of automation platforms. I'll just discuss from the data center perspective, which is more like UCS director. Orchestration and automation is what we use there. Then the SAN series is basically FCOE and FC SAN products plus SAN switches. And Cisco security products, you have majorly what we need to know from CCI data center perspective is ASA firewall, because they do have a couple of questions on that. So you see that Cisco basically has these products and the certifications are mapped to these products. So when we do routing and switching, we basically focus on these certification is basically RNS, we call it. Okay, here what do? We do service provider. So CCNP service provider, CCNA service provider, etc. This is collaboration track. Okay, and this is basically more like your data center. Then they have wireless track. Then they have basically they have now UCS, CCNA cloud, CCNP cloud, and this is all covered in the data center. Most of it right now is covered in the data center. And then you have CCI security tracks. So this is how the CCNA, CCNP, CCI tracks are there. This is like CCNA wireless, CCNP wireless, wireless to CCI wireless, etc. Okay, so we are at this piece of it where we are actually going to discuss about Cisco NX OS and why the operating system is different, why Cisco required a different operating system basically. Okay, this is the most important thing to understand. And as you can see that the iOS series was for something else, for MPLS, the best of L2, L3 VPNs. They had the XR series, which was designed for it, MPLS thing. And then you had Nexus OS. Okay, so this is the core of our learning, and as we can see here on the top of it, we have to understand what is NX OS and the operating system related stuff. We'll come to the planes and other things later. So why was there a requirement for the NX OS operating system, and what is that we were basically lacking in the enterprise iOS operating system? So I'll just pick up one interesting document here.
Sir, I cannot hear you.
Okay, you couldn't hear that?
Yeah, I couldn't hear.
Okay, sorry. So Cisco basically built a completely different operating system for the data center products, because data center had a very different requirement. Okay, You required virtualization at multiple places. You were basically dealing more with servers, and you were dealing less with the host or the laptops and other things. You hardly deal in the data center with wireless, so that is not a requirement. So here are a couple of features which are actually given for the NXOS. And so unified data center operating system. Now, when you say unified, it has a very deep meaning. So this unified basically means that the operating system is designed in such a way that it can support LAN, SAN, and both LAN and SAN environment plus the server environment, which is UCS environment, in a single operating system. So it unifies everything. It unifies LAN, SAN, and the server part of it. Okay. You can read these words. These are very interesting words here: modularity, flexibility, scalability, virtualization, resiliency. So here are basically, these are the terms, and here are the real concept, which was not actually there in the operating system of iOS. The Cisco had. Okay, the first feature that we have is VDC here, which is nothing but breaking a physical switch into multiple isolated small switches. We've seen this concept in VMware where you pick up one huge server, right? And from the server, you assign small resources to multiple servers, basically. So you basically are separating a couple of servers from each other and still getting the resources from the main central server capacity. So here you have a single switch. Pick up MS Paint, and I'll explain you in easy words. Okay, so what really happens is, let's say you have a one big switch, and so VDC gives you a flexibility of breaking the switch into multiple virtual switches here. So one single switch, you can basically, what you can do is you can pick up certain ports from here, and I'll put a different color here. And this will become one virtual switch. You can assign it to different set of customers or the users, depending on what is that you have. Now, data center, also we have to understand is data centers are very different from enterprises. In enterprise, you don't share your infrastructure with anybody else. In data center, basically what you do is you have tenants. So in one data center, you basically share your resources with multiple customers. Sometimes that goes into thousands. Right? Guys, any confusion on that? So basically, we have a concept of tenants here in data center, which is not there in the enterprise environment. So you never required virtualization when it comes to, or switch virtualization when it comes to the enterprise. Very interesting thing what happened is that Cisco Nexus products were actually designed for data centers. Okay. But because of these amazing features, even enterprises started buying the Nexus switches. And today you see a huge number of Nexus being sold into enterprise environment, because these kind of features not only are very useful in data center, they are very useful in enterprise as well. So what happens here is, from one big chassis, one big Nexus 7K kind of product, you have the luxury to basically break a couple of ports and can assign it to one virtual switch. We call it VDC, Virtual Device Context. VDC2, VDC4. Okay. So this is how you basically break VDC. Now, I didn't want to go into 7K, but it is actually, to explain this concept, we have to get into the 7K itself. So as of now, VDC feature is only supported on the Nexus 7K products. I'm sure you have seen 7Ks. I've seen 7K products. No other product in the Nexus series as of now supports VDC concept, virtual device context. All other products basically are, like 5Ks are like this. You have basically one RU or two RU, but 7K platforms, you might have seen the models and other things are basically like you have 7004, 7010 was there, 7018 and other things were there. So there are huge chassis. Okay, let's see one of those. Okay, these are modular chassis. So when we say modular, if you look at this chassis, you see the chassis is huge and it has modules. So this looks like 7018. You can have up to 18 modules. Sorry, 7018 is not 7018. You can have 18 modules here, including 2 supervisor modules, which I'll explain in detail when we get to the chassis level. So one of the most important features that you have is you can break your switches into multiple small switches as if those are completely isolated from each other. Okay, this feature was not there in any of the iOS product as of now, in any of the Cisco product router or switch that you have. Then they have a port channel concept, which you already have in the the iOS switches, but here you can have a virtual port channel which can combine multiple port channels. Remember that when you create port channel, right, between 2 switches, how many ports can we have in a port channel, guys, in iOS switches? How many maximum port can we put in a port channel? We generally can put around 16 ports. In that, 8 ports will be active at one time. Okay, 8 ports will be active in a port channel in from your CCNA, CCNP perspective. Right? But the problem with the data center product is the data center requires more than that data center is basically requires more bandwidth, so it requires more than one port channel. What if the port channel only supports 8 active links at one time? What will you do? You need to have a second port channel. But can you have second port channel, guys, between 2 switches? In the iOS switches, can we have second port channel as well between 2 switches? Right? The spanning tree is going to block it. So spanning tree doesn't allow 2 port channels between a pair of switches. So between this switch and this switch, spanning tree will never allow you to have more than 1 port channel. And one single port channel can have how many active links? 8 active links. Data center is all about bandwidth. Data center is about how much more bandwidth can you basically provide to the customer. So those principles of port channel are not great here. So what do? We have the second concept after VDC is called VPC, which is virtual port channels. You can have 2 port channels bundled into 1 port channel. Okay, so you can have multiple port channels bundled into 1 port channel. So that's called virtual port channel. And then you have continuous system operation. The operating system is designed in such a way that you will not have failure of any type. Okay, whether it's the physical or the logical or operating system base or configuration failure, it will actually protect you from any kind of thing happening in the data center. Okay, let me take an example here. Okay, before that, let me go back to the value of this program. I'll just give you a hint of how much money is on stake. Okay, so you see that here. Amazon found that every 100 millisecond of latency, not even a second, every 100 millisecond of latency costs them 1% of sales, or 1 second can cost Amazon $1.6 billion in sales. So if you're in the company, right, if you are in your company and the internet doesn't work for a couple of seconds, that's absolutely fine, right? The max what will happen is there will be downtime, the bosses will be angry, and there will be no email, your IP phone calls may drop and other things, which will still create a lot of problem, but may not create a kiosk like, here you have $1.6 billion lost in sales in 1 second of delay. Okay, and that's just a slow down of it. What if actually your switch reboots? These are all heavy duty switches. If these switches reboot, what happens is they generally take around, a Nexus 7K switch takes around 5 minutes time to actually come back completely, right? So let's take an example. You are in the data center, you are the engineer here, and we have a huge number of servers, and you are Amazon, and you basically have customers. Okay, and basically as soon as they come from the ISP router, they will hit the switches, Nexus switches here, and after Nexus switches, you have a huge number of servers. What if I have, okay, I'm on a Nexus product, and I have a requirement to upgrade my OS. What if there was a bug in the old operating system? Cisco issued a warning that you should upgrade your 7K immediately so that the vulnerability that you have in the operating system is covered up. Okay. Now we talked about what if it's an iOS router, right? What happens in iOS router? You guys have pretty good experience on Cisco iOS, CCNA, CCNP level routers, right? So what happens if you have an iOS switch or iOS router? You put the image into it, and then you have to reboot it so that you can actually boot it using the next image. So if you had an image called 11.2, right? If you had an image called 11.2 and you want to upgrade it to 12.9, what do? You put the image, copy TFTP or FTP or SCP into the switch, and then you have to reboot it so that it reboots using this image, because before upgradation, it has booted using which image? 11.2 image. So if you want to cover the vulnerabilities, what will happen? You need to boot it using this particular image. Now in data center, I just showed you an example, $1 billion loss for 1 second of latency. What if 7K takes around 5 minutes to come back? 5 minutes of time. That's a general time it takes to come back. Okay, so two situation arises. What says that you cannot update it ever? Okay, which is a bad idea. So Cisco created an operating system which will take care of, it's called InService Software Upgrade, ISSU. InService Software Upgrade. Cool. You could be in operation and your image will still be upgraded. Even if you boot, even if you reboot, okay, even if you reboot, you still will be operational. Is it possible if the device is rebooting, you are still operational to the customer? Guys, is it possible?
Yeah.
Okay, so that's not possible, right? It won't be possible because if your device is rebooting, you basically, so what they do is the whole operating system is designed from software and hardware perspective in such a way that you have a redundancy for everything. So I'll talk about redundancy, what they were calling the resiliency and everything else there. So it has dual supervisors. This is the brain module. This is where the operating system stays there. So those are called supervisor modules, and it has two of those. Okay, and that rest of the modules are known as I/O modules. These are input output, like you have the ports. Okay, the ports. So this is where the brain is. The supervisor modules are the brain. Okay, and these are the I/O modules, which basically take instruction from where? The brain. Now, because you have two brains, one can go down, one can, so if I want to upgrade something, what I'll do is I will upgrade the secondary one. Although I'm going to take you through the process later, I just am explaining, from very basic perspective, just to give you an overview of things. That it has, so it will go to the secondary one, you upgrade the image yourself of secondary, then the secondary will actually, basically be rebooted with the new image, and you are sitting on the active right now. The switch has not rebooted. What has rebooted? The supervisor module. So if you were actually on the image called 11.1 and you are basically upgrading it to, let's say, 14.1, so whom are you upgrading? You are just upgrading the supervisor module. Supervisor has all the brain. Okay, so while this is getting upgraded, the first active one has no dependence on the secondary one. The secondary only takes over when the active is down. Okay, so you upgrade it and then it reboots on its own with the new image 14.1. Okay, and then you can upgrade, and then this guy will switch over to this guy when you are upgrading the secondary, or which was active one. Now active becomes secondary and this guy becomes active. Okay, not only that, I'll give you a lot of other perspective. What Cisco does is they have dual, so basically they take care of the fan failure. Let me say that. They have multiple fans. Power supplies, they have multiple power supplies. So if one power supply fails, you can still work on the secondary power supplies or the other power supplies you have. So not only from operating system perspective, but from hardware perspective also, things are designed such a way that everything has a backup. Some of it is in the operating system, but the operating system is closely tied to the hardware part of it. So if fan fails, it will tell the operating system the fan has failed, and the operating system will basically send an alarm to admin that you can go ahead and replace that fan. And let me ask you this thing. Okay, the fan of your laptop or computer gone bad, your desktop or laptop, the fan is gone bad. What will you do? Can you still have your computer active when you are replacing the fan?
Cannot.
We can't, right? So here, the beauty is Cisco understood everything, and they said, data center means no downtime. There is no possibility of downtime, especially from Cisco perspective. They see there could be human errors, there could be other, catastrophic reasons, earthquake or something else, which are not in human control. But from the device failure blame or the downtime blame should never come to Cisco. Okay, so from their product design perspective, they have designed everything redundant, and it has a close integration with the operating system. Now, I'm just giving you the tip of iceberg. Okay. So the feature of the operating system has amazing features, which is I just told you IISU, and then it has checkpoints. So by mistake, if you make any mistake, every time you save the configuration, Cisco saves your configuration into checkpoints, and you can retain. It's like, you know, you on the Windows computer, you have that backup restore point, right? You have the restore point. You can always go back in time and you can restore your computer to the well-known good configuration, right? Windows had this feature for almost 10, 15 years now. So here also you have a checkpoint option. Nexus products take care of checkpoint on their own, and they can restore it on their own if there is any malicious thing that happens. The second thing that's possible is that you can create your checkpoint yourself as well. The NXOS operating system gives you checkpoint, the feature basically. Okay, so two ways it is covered, right? Then there are a huge number of features as well. So this is where we were talking about the in-service software upgrade and a lot of other features which will take care of any kind of downtime. So it is designed for data centers, and data center mean no downtime. Okay. So when we actually go through the whole curriculum, we have to keep in mind that all our thinking have to be from a perspective of that no matter what happens, there should not be any downtime in a data center. Because, you know, in data centers, you have the websites, the WhatsApp and Netflix of the world, which is basically serving in different time zones, and they are always up kind of service. And then you have security. So Cisco has very advanced security available, all kind of cryptography things. The next feature we have is basically OTV, which is a very interesting feature, which is now picking up, and which is basically more like a VPN service. It's like your IPsec VPN, and but it's a L2 VPN, so you can correlate more it to MPLS kind of thing. So it can give you L2 connection between two sites. Let me draw an example here. OTV can connect two of your data center using Nexus switches. So if you have a 7 key here, you have a 7 key here. You can basically have an ISP connectivity between them, and it can take your ISP connectivity and you can basically transport it. Let me say you have VLAN 10 here and you have VLAN 10 here. These are two of your data centers in two different countries, right? Using a layer 3 connection, you can still have L2 connectivity between these two. Okay, so if a customer basically was primarily served from here and something happens in this location, you can actually, the customer can be served at this location with the exactly same VLAN and IP addressing. Okay, very powerful feature. And L2 over L3. So it's an L2 VPN. It's like MPLS. You require L3 to carry it, and you can still have L2 complete L2 functionality. The next thing we've talked about is basically the same thing I was talking about, checkpoints, that you have a feature called persistence storage services, which is built in NXOS operating system. Is nothing but a lightweight database that maintains runtime information of the state. PSS provides a reliable persistent storage in the software component to checkpoint their internal state and data structure, enabling no disruptive restart. If a fault occurs in the process, let's say in OSPF, the high availability manager will basically can restart just the OSPF part of it, or it can move on to the other supervisor module. So if there is any kind of problem, it will not reboot the switch. It will either restart the process, okay, or it will restore it to the checkpoint, or it is going to, if still it's not working, it will move it to the secondary brain, which is redundant supervisor module. Okay. And then we have Fabric Path, which is actually is a very unique new product, and it replaces spanning tree at the core of the data center environment. See, spanning tree, the problem with spanning tree is the spanning tree is all about blocking the links. Spanning tree says, I will not allow more than one active link from one switch to another switch. Right? You don't invest so much of money. You don't generally invest so much of money to have a switch which is actually going to block more than one active link from one switch to another switch. Data center is just opposite of it. Data center means you need to have more bandwidth available. And so basically what Fabric Path kind of features will do in your data center is that you will have, if you do not run spanning tree, in this link you have a choice to run spanning tree. What will happen? Spanning tree will permit one link, will block the other link. But with Fabric Path, you can have up to 16 active links, 16 port channels, which will actually give you up to 256 links active simultaneously. Okay, think about 10 gig link or 40 gig link kind of things. So how much bandwidth you basically are going to have. With the Ethernet, with spanning tree, what will happen? Spanning tree will give you maximum 16 links at one time, one single port channel. Here, you know, if you have second port channel, what will happen? Spanning tree will block it. Spanning tree will never allow it. So what do? We basically go with the Fabric Path feature, which will allow 16 port channel between two switches, any two random switches. Non-blocking. So we replace spanning tree completely from data center environment in the core. Okay, so these days you see VXLAN and Fabric Path. So Fabric Path and VXLAN are exactly same in behavior. In the background, they both use Fabric Path and VXLAN. They both use ISIS protocol, right? And ISIS basically is a link state database protocol, which takes care of the routing between these. So no more switching, you know. So L2 routing, I'm not sure if you've heard this term again in your life or before in your life. L2 routing. So Fabric Path and VXLAN provides you L2 routing, layer 2 routing. Okay. So those are amazing features, and the whole operating system. So these are the core of it. You know, if you ask me, what are the 5 or 6 things which actually make the NXOS operating system different from you know, any other operating system, is basically these features. Now coming back to the common stuff, you know, what are the common stuff which is supported? So.
Vikas, I have a question. So when we talk about these switches and we talk about port channels and all things, I'm not sure about everybody else, but I've not worked on switches in the past. So are we going to cover this, or do I have to go ahead and do my homework before coming?
I would suggest you to have a little idea about all these things, because the syllabus doesn't really cover much of the theory of spanning trees and routing protocols and all that. You know, the syllabus just tells us to actually tell how does it, you know, how do you do the implementation on a Nexus switch.
Perfect. No, I know about the spanning tree and the routing protocol. It's just that it's a long time back when I used to do this. Might need but I understand that. Okay, cool. I'll just go through that.
Right. So port channel is a topic which I generally explain in detail, and I do a lot of practicals on that in the CCNA data center itself. So maybe port channel may not be required. Yes.
Oh, perfect. That's the one. Okay, great. Thanks, man.
Sure. So here, the ordinary stuff which basically is supported is your all routing protocols, including RIP, AIGRP, OSPF, ISIS, BGP is supported. In MPLS, you have all kind of MPLS. All MPLS types are supported. SAN, you have FC, and FCOE supported. And all the ordinary stuff, basically, whatever your Cisco IOS router supports, like HSRP, DRRP, GLBP. So all iOS features, plus those 5 or 6 things that we talked about in the NXOS operating system. So it supports everything else that the iOS switches have. Almost everything, even more than that. And these additional things. And so these features are actually known as core data center features. Okay. Although 70% of the syllabus for NXOS will actually still revolve around doing routing protocol or the switching or spanning tree and some of the stuff where we are going to do a lot of practicals on those. But you know, the focus of the whole learning should be these 5 or 6 features, because this is what is, you know, making an NXOS operating system switch very different from iOS switches. And it actually alters the behavior of many old technologies. Like we talk about VPC. VPG changes port channel behavior. Okay, we talk about OTB. OTB changes a lot of different things in spanning tree and other things. Similarly, if we talk about VDC, a lot of stuff that we have never experienced in iOS devices, we will experience. And fabric path, again, is like you replace spanning tree. You don't really require spanning tree at the core. Complete replacement of spanning tree, you know. And then you see the amazing booming, you know, effect of huge speed available, and you know, basically, well, what we call it, unbottled core. So no bottleneck. There is no bottleneck. You can have 256 links possible with the 10 gig or 40 gig kind of bandwidth, and that makes it really amazing. Okay, so that was about NXOS operating system, and you can find a lot of other interesting stuff. Let me show you one of the thing here. There's something called Cisco Mickey. Okay, here it is. Okay, so this is a detailed explanation of what is the change in Cisco IOS CLI and NXOS CLI. What features, how it's different, etc. And then you can have huge number of commands on NXOS operating system for show commands. You can see it's a great article. I'll put it into the chat window for you guys. Okay, then the next thing we have to do here is Nexus 7000. Okay, so this website is very important, docwiki.cisco.com. Okay, it's especially for the data center. If you want to see any kind of implementation, how do you do those implementation, you know, you can actually find, it's like more of a configuration guide kind of stuff. It explains you how you do in iOS routers like BGP and what is the difference in NXOS CLI. It will tell you the different types and all that. And it will give you the NXOS commands for the BGP or any other topic, basically. So this is all NXOS implementation, which is a couple of commands different and nothing major different out there. Okay, so what are the products Cisco line has in the NXOS series? So we are actually, at the time of UCS, we will do UCS. At the time of ACI, we are going to actually discuss in detail the 9K series. I'm going to discuss more about the 7000 in the other series of products. So these are all Nexus series of products, but some of these series can be converted to the ACI series, and then they will actually lose all NXOS features, and they will be completely working in a different way. So the major product series that we have right now, which is going on, is 9Ks, 7000. So 9Ks is, you can just label it like more of a ACI, although 9K does support NXOS. So 9K product line, basically this is how it looks like. These are the products available in 9Ks. Mostly 9Ks are used for ACI. Okay, but if you want to lose the ACI functionality, you want to have it like the standalone switches. You don't want SDN features and all that. You can basically make them as the standalone NX operating system. Otherwise, you can put ACI software into it, and you can do the practicals basically. The major focus of CCNA data center when it comes to Nexus is 7Ks. Okay, so 7Ks right now has two series, 7000, which is actually end of sale now, and 7700, which is actually the new series with the better modules and all that. So basically, these are like the car module, the car models that you have seen. It has the same wheel. It's got almost the same stuff, except the engine is different. So most of the new product series that you have is what is different. If you ask me straight, one difference or two differences, most of the features are exactly same. Is the module type, which is like 40 gig per interface or 100 gig per interface, that kind of bandwidth. So if you look at these 7K switches, they could actually go up to 1 gig or 10 gig maximum. They will not support a 40 gig interface or a 100 gig interface or a 400 gig interface at this time. But a couple of these switches, the new ones, 9Ks and 7700, they do actually support the latest modules. Okay. Now, when they have those amazing modules, the big modules, of course, the throughput or the what do you call it? Throughput of the whole switch actually increases. So there are two things: throughput of the interface, which I was talking about, 10 gig or 40 gig or 100 gig interfaces, or throughput of the whole switch. So here is an example. The Cisco Nexus 7000 series consists of these. The latter being updated series of this. Cisco Nexus 7700 series offers higher bandwidth per slot, which is 1.3 Tbps. As compared to 550 Gbps in the 7000. So what was the 7000 maximum? 550 Gbps. And what is a 7700 can offer you? It can actually offer you the backplane capacity. And tomorrow we are going to do the backplane capacity calculations and other things. Today you can just basically go with the words. So this is the backplane capacity of the whole switch. And this is again, the older switches only support half of what it is basically here. So as I was talking about, the only difference is greater performance. It's like the cell phones, last cell phone you had was 2 GB RAM, then you have 4 GB RAM, now you have 6 GB RAM and a better processor and all that. So almost similarly, you have the performance difference, but when it comes to operating system, the operating system is exactly same. Again, comparing to the cell phone model, the mobile model, you can have Android into 2 GB. The features are same, no feature difference. It's just the performance, right? So if you have a 6 GB RAM phone, you still get the same operating system. Only thing changes is it has the higher RAM, the higher CPU speed, so it gives you a little faster communication. So here also is similar. Then the series of the product, 7004, 7009, 10, and 18. And 7700, you have two modules, 6, 10, and 18 slots. So these are like the number of slots possible. So of course, if you have more slots, that means you have more capacity, right? You can serve more customers, you have more ports, right? So when you have more slots, you have more ports. When you have more ports, you can serve more customers, right? So this is how, so if depending on your company or your data center size, you can choose to buy one of these chassis and probably 2 of these for backup, and you can, so these are 7,000 product series. After that, we have 5,000 series, which is again divided into 3 series. It was 5,000, 5,500, and 5,600 now. So what is the major difference between 7Ks and 5Ks is a lot of features are actually not supported on 5Ks. Okay, and these are always 2 rack unit or 4 rack unit maximum if you see this model. But these can go up to 18 rack units, so 18 are used kind of thing, right? So 18 modules means 18 rack U kind of thing. Here you have, these are mini switches. If we talk about the old, the concept, we can call them the core layer switches. 7Ks are core layer switches. And here you can call these people as distribution layer switches. It will not be wrong to say that. Okay, what's the difference between multiple models? You can see that this switch has 40 Gbps per port. Okay, and it has 24 ports. This is 48 ports. So that's 24 ports, 5624, 5648. Q is basically QSFP, which is basically 40 gig and more. Okay, these are ordinary, no Q behind it. So these are maximum 10 Gbps per ports. Okay, so different series of product. This is like distribution, that was like core. In Cisco Nexus 9Ks, you don't really have that kind of concept. There we have in ACI, we have leaf and spine. Okay, then we have 3K series, which is actually a recently kind of, not very recent, but recent as compared to the previous switches. Because 7Ks came and the 5Ks came and then the 4Ks came, which is actually dedicated for IBM. Cisco manufactures and they have a licensing agreement with IBM. So 4K is not a Cisco product anymore, it's given to IBM. 3K is what Cisco has, and this is like, it is more, you can call it again, distribution layer switches in smaller data centers. It can support routing and switching and other functionalities like these people can support. Okay, all routing protocols and other things. It can also support all that. So if you have a smaller data center, doesn't have much requirement, you can use this. Then we have 2K switches, which are actually known as fax switches, fax technology. Okay, so these are like access layer switches. This is exactly where the server connects. So all your servers are going to either connect to that, and if you actually do not have a budget for these, you can actually buy the old 3750 or IO switches at access layer. That will also be fine. Okay, so a huge number of people find these switches a little expensive, so they don't really use it, but there are a huge number of benefit you have when you use fax. Okay. Now, I have to explain here a little bit about fax in this particular scenario. So I'll take the example of a traditional switch. Okay, I have this particular 7K with 18 modules, and let's say I have all my ports filled up. All my ports are almost going to be full. Okay, all my ports are going to be full. So what do? I need to connect more servers. So I can connect a fax, which is a 48 port or more, or the 32 port or more. It can go up to 48. So let's say I connect a fax. So what happens with this fax is that you actually added, end up adding these 48 ports to this switch. So if this was 7018, remove 2 supervisor modules from it, you are left with 16 IO modules, right? When you actually remove the 2 supervisor modules, 2 soup modules. Tomorrow I'm going to get into detail of the backplane modules, IO modules, the supervisor modules and all that. Will go into detail of it. So what fax basically does is, it will add one more module kind of thing. With 16, you have now 17 modules basically. So all 48 ports will become part of it. This switch has no console. So if it doesn't have any console, what will you do? You have to manage it using 7K itself. Right? Now think about if you had to add another module here. One thing is this is all full, you don't have the space, number one. The second thing is if you have to add, in a powered Nexus environment, you may have to switch off the switch. You can't put an electronic card, it's not hot swappable kind of thing. So you have to basically switch off the switch and then add an additional module to get 48 ports to this. So fax can basically, you can have up to 20 faxes connected to one switch, which basically gives you 40 into 20, 48 into 20 kind of ports. That's a huge capacity. Guys, any confusion on this?
Oh, Vikas, when we talk about fax, I mean, it can be any switch that we can connect to the, I mean, we have one.
It's a pure NXOS operating system. So it will only be supported on a 7K and 5K and no other platform.
Oh, yes. So if we have a 7K switch and with one specific port, we want to connect another switch, we can have a 7K switch connected to it, correct?
Can you say that again, please?
So we have a 7K switch and we have all the ports almost going to be full. So to one port, we connect a specific one more 7K switch to increase its capacity, correct?
No, it's basically you connect one fax. So you just pick up this 48 port switch, connect it to one of the port here, and then this port will basically, although it's going to act like a trunk, okay, it will actually add 48 more ports here.
Okay, yeah.
So from management perspective, yes, you have 48 more ports being added to you without powering off anything, without powering on anything. You actually added kind of a module here. See, the second option we have is we can have an old iOS switch connected to it. Okay, so that is also an option available that you pick up two ports here, 20 gig to 10 gig, 10 gig. And then these, again, 48 ports. So an old 3750 iOS switch will also give you. The problem with this is then you have to go to the CLI of this particular switch and then configure it. Right? Which VLAN, which port to put in which VLAN, all 48 ports and all that. With fax, what will happen is you don't need to have a console on this device. This will be actually managed using this device. This device will give control to this device itself. So the parent device, we call it the parent device, we call it the child device. Child device will give the control to the parent device and parent device will do all the configuration. What will happen? You are eliminating one more point of configuration in the network. What if you have 20 switches? Would you like to go to the 20 places to do configuration? Doesn't make any sense. You can have 20 switches all being managed by this guy. So he is, now this is very interesting. So let's look at this switch. When I say 18 modules here, right, or 16 modules, leaving two supervisors here, what is that I'm saying? In the older time, when this concept was not there, what was the solution? The solution was actually to have individual switches. And then came the stacking, right? You had the stack cable, and that will give you up to certain number of switches, not up to 16 kind of thing, but stack will give you certain number of switches and all that. So this is what we used to do at one time. We have to go to each switch if we are not using stacking, and you have to configure 16 switches. Here in Nexus, all these ports are like module. You have 48 port, 48 port, 48. All of these are 48 ports. So you are one big switch containing 16 switches. What's the benefit? You don't have to configure 16 switches at 16 consoles. You can buy one Nexus 7K switch and you can manage, using one single console here. Right? So that was actually the purpose of having 7Ks, where you can just have one switch and you can configure things using this particular switch, one single switch. Fax even makes it more beautiful Because if you are running out of your capacity, even after 16 modules, you do not have many ports left. What you do is just pick up 1 or 2 ports and add 48 more ports of this particular device to your switch. And then connect servers here. Okay, guys, any question that we have on this? So this is 2K. The 2Ks are dedicated for fax. You see that they do not have any console port. Why? Because they will never be configured locally. To an extent that their operating system will also come from the parent device. They don't have any operating system on their own. You know, when you plug it to a 7K, a mini operating system, this switch will boot itself from a 7K given, the port basically, or the operating system. Right? So they don't even have an operating system on their own. They actually boot up using the parent device. And that's the reason we call them as remote line cards. See, they are acting as line card, but they are actually not on the physical 7K chassis. They are actually outside the body. Okay. After that, Cisco doesn't have any physical switch after this. Cisco has a virtual switch after that. So if you want to replace VMware vSwitch or DVS, distributed virtual switch, and you want to have more features to that, you can buy Cisco Nexus 1000V, which can actually give you all switching features. You know, I'm not sure how many of you have used DVS in the VMware. Anybody's got experience on VMware where you have used the distributed virtual switch? It has a virtual switch. The VMware server has a virtual switch, but that is very basic virtual switch. It doesn't have features like private VLANs, right? IP source guard, DHCP snooping. It doesn't have all those advanced Cisco features, right? So Cisco, what it did is it extracted all those physical features of operating system and actually is trying to replace VMware switch, basically. Okay, and VMware at that time did not have an enterprise level switch. So VMware did allow Cisco to go for an integration and replace their own switch with in the VMware products. Okay, but now VMware has a much more advanced switch on their own called NXS, which could give you virtual router, virtual switch, virtual firewall. NSX has every single thing possible. But at one time, they actually had a dependency on Cisco. Now Cisco is pitching because VMware is gone. There are a couple of more people left. So Cisco is now pitching it to Azure, AWS, and a lot of other virtualization platforms, including Citrix and other people. Okay, so this is basically a pretty advanced switch. It has all the properties, but it's a software basically. It's just a VM. It's just a VM. It operates inside VMware this and NXOS. It runs NXOS. Okay, then you have Cisco Nexus 9Ks, which are SAN switches. And as we were discussing about, we have a full chapter on SAN as well. We have to do FC and FCOE practical. I will show you MDS practicals, how to do the things on MDS switches and all that. Okay, this is exactly almost the similar stuff, same. So another article which tells what are the benefits of having a Nexus OS kind of thing. Yeah, I'll send you this in the chat window. Tomorrow I have to find out my folder where I have all the materials. So tomorrow I'll give you the book, and I have a folder where a couple of videos are there for data center technologies at NA, NP, and I level. So I'll share tomorrow all those details. So this is today's introduction class, guys. Tomorrow we'll get into the hardcore features, which will also consist of the practical on a 7K, the basic creation of VDCs, how to check all the modules, how to check power supply, how to check environment, the failures, logs, and how to create the users, admin users, and the different kind of users it has. So this was more like an introduction class. Now these features will actually open up more and more in each class that we basically do. Like we do it tomorrow, we'll do a class on VDC, right? Virtual device context. Then we are going to do a routing practical between VDCs, which will cover VRF. Then we'll cover spanning tree. Then I'm going to cover port channels, and then I will cover VPC and all those things. So every day, one chapter, one topic will be basically covered in detail. So today was more like an introduction. Okay, it's a good article to read. Basically, none of the book covers the core and the juice of the features like these 2 pages that I've shared. Right, guys. Any question, guys?
Vikas, to do the practicals with you tomorrow, do we need any software on our end?
Not really. So I'm going to do the practical and I'll show you.
Okay, great.
Yeah, so everything will be recorded as well. So whatever lab I do, it will be actually recorded, and you will have recording on, as I've given you today, option to record. After the class is over, you will see it will actually be in your documents folder. This recording will be there. If anybody misses out on any day, I'm recording the class, so next day I can actually send you the recording.
Vikas?
Can you hear me?
Yes, I can hear you. Yes.
Yeah, tomorrow I'm planning to let's travel from North Carolina to Texas, so maybe I'll not be able to attend the class. And please give me a record after finish the class, and I can cover.
Excellent. Yes. So that's the reason we do recording of each class. So if you miss any of the class, next day I'll send you the folder. I'll give you one Google Drive folder where all the classes will be in the single folder day by day.
Okay, so I have planned that's back and forth on Thursday, so I'll miss 2 classes, Tuesday and Thursday. So please give me the record for that one.
Sure. I'll do that. Yeah.
Okay, thank you.
All right. Excellent, guys, and I'll see you tomorrow then. Take care.
Okay, bye.
Bye-bye.
Sure. And Vikas, one more thing. If there's anything that you want us to go before, for the next lecture, if there's some prerequisite that we need to go for beforehand, just let us know so that I can just brush up those things.
Yeah, so if you go through these 2 links that I sent today, that will be great.
Perfect. Got it.
Thanks, guys, and I'll see you tomorrow. Take care.
Thank you, man.
Thanks.
Bye,
Bye-bye.
guys.
Bye, guys.